Welcome back, Mr. Sutton here, bringing you the AB Calculus 3-8 Extra Practice number 5 solutions on implicit differentiation. For this problem, we're trying to find the derivative at the point 2, 8 for this weird-looking function. Now, since this function is difficult to isolate y in, or possibly impossible, we're going to go ahead and use implicit differentiation, and then we'll plug 2, 8 into whatever the result is. So going from left to right, taking derivatives with respect to x derivative is just going to be 1. And then the derivative of 3y to the 1/3, using the power rule here, that's 1/3 times 3, which is just going to be 1. Y to the, let's see here, subtracting 1, that's going to be negative 2/3 power. But we have to multiply by dy over dx because y itself is an inner function of x, so we have to use the chain rule. And then this is all going to equal the derivative of y, which again is dy over dx. All right, so now we have to isolate dy over dx. We can do that by subtracting one of these from one of the sides. And this is one of those half a dozen of one, 6 of the other situations. But just to be consistent, I always like to have my dy over dx's on the left side. So I'm going to keep this y to the negative 2/3 dy over dx over on the left side. And I'm going to subtract this other dy over dx to be there with it. And then I'll subtract this 1 to move it over to the right side. Now that I've done this, I can factor out dy over dx, leaving me with y to the negative 2/3 minus 1. And I'll just divide negative 1 by all the stuff in this parentheses to get my final function here for dy over dx. But I'm not quite done with the problem. I still have to plug in the point 2, 8. So looking at what I have to plug in here, there's nowhere to plug in x. So all I can do is plug in that 8 into y. When I do that, I'm essentially going to be doing 1 over the cube root of 8 squared. So I'm dealing with this situation here. And unfortunately, this is none of the answer choices. I mean, why would it be? It's kind of gnarly looking. So we're going to have to simplify this. So the cube root of 8 is 2. Squaring that gives me 4. So this is really 1/4. 1/4 minus 1 is 3/4. So I have negative 1 over negative 3/4. And let's see, negatives cancel, same change flip. This ends up being 4 over 3, which is answer choice D. On this one, I'm trying to find the slope of the tangent line for this curve. Since y is not already isolated, I don't have to, but I'm going to go ahead and use impdiff on this one. Seems like a good way to go, especially since they gave me an x and a y value. So I'm going to rewrite this with fractional exponents to start. This is x to the 1/2 plus y to the 1/2 equals 2. And then taking derivatives with respect to x from left to right, we have 1/2 x to the negative half plus 1/2 y to the negative half. But y is itself an inner function of x. So we have to use the chain rule here and multiply by dy over dx. And then that's going to equal the derivative of 2, which is 0. Okay, let's isolate the dy over dx term. I'm going to just subtract this x term over to the other side. And I'll just divide now by 1/2 y to the negative 1/2. And now I've got dy over dx isolated. Before I plug this in, though, I'm going to clean this up a little bit here. So these 1/2s can cancel. The whole fraction is negative. And these negative exponents, I'm just going to switch x and y. So this is really y to the 1/2 over x to the 1/2, which is to say we have the square root of y over the square root of x. And again, that whole fraction is negative. All right, let me go ahead and plug in 9/4 and 1/4 for x and y here. So that's going to be negative square root of 1/4 over radical 9/4. And then we've got, let's see here, this is negative, this is 1/2 up here, and we have 3/2 downstairs. Same change flip, we've got 1/2 times 2/3, that's going to be 1/3, and again, the whole thing is negative. So negative 1/3, that's going to be choice B. For this problem, we're trying to find the slope of the tangent line to this crazy looking curve at the point 1, 2. So there isn't really much of a choice on this one. We can't isolate y. We're going to have to use impdiff or just kind of give up. But I'm not giving up. Let's use impdiff and see if we can get dy over dx isolated that way. So going from left to right, we're taking the derivative of y with respect to x. Every time we take the derivative of something with y, y is being treated as an implicit inner function. so we have to give it a dy over dx tail using the chain rule. So this first one, we've got 3y squared times dy over dx minus, well, now we have to use the product rule here, so let me set up a box and ribbon to coordinate that. So one of my factors I'm going to call negative x, and I'll have y squared as the other factor. Derivatives of these, we're going to have negative 1 for negative x. Y squared derivative is going to be 2y dy over dx. Multiplying that out with the ribbon now, we've got minus 1y squared, so minus y squared. And then this is going to be minus 2xy dy over dx. And what else do we have? Oh, wait, there's more. We have an x cubed to take care of. That's going to be plus 3x squared. And don't forget the other side of the equation. Right now that's 5, but when you take its derivative, you get equals 0. All right, so this is a little bit of a mess. We're going to try to get dy over dx by itself. To do that, we're going to keep anything with dy over dx on the left side, move everything else to the right side. So staying on the left side, we have 3y squared dy over dx and negative 2xy dy over dx. Moving to the other side, when I add this over here, I've got a positive y squared, and I'm also going to have a negative 3x squared when I move this over here. All right, let me factor out dy over dx. So that's going to be 3y squared minus 2xy inside there. And then I'll just divide by that parentheses to get dy over dx by itself. So at the end of the day, I have y squared minus 3x squared over 3y squared minus 2xy. That is my dy over dx formula. But I'm not done yet. I still have to plug in the point 1, 2 to get one of these answer choices. So let me go ahead and do that. So plugging in 1 for x and 2 for y. In the numerator, I've got y squared, so that's going to be a 2 squared, minus, this will be 3 times 1 squared, over, this will be 3 times 2 squared, and we're subtracting 2xy, so that's minus 2 times 1 times 2. All right, let's crunch these a little bit further here. So in the numerator, I've got 4 minus 3, so that's 1. Denominator, this is 3 times 4, so 12 minus 4, that's going to be 8. No need to simplify that any further. We just get answer choice B. For this problem, I'm trying to get dy over dx for this tangled looking equation. Since I can't really get y by itself, I'm going to use impdiff, implicit differentiation, on this. So taking all the derivatives from left to right of y with respect to x, I've got a chain rule to deal with on the left side. This is sine of something, so the derivative of that is going to be cosine of something, cosine of x plus y. But now I have to multiply by the derivative of the something. Well, the derivative of x plus y is going to be 1 plus, well, this would be 1 normally, but since y is itself an inner implicit function, we have to take the derivative of y with the chain rule, so that's going to be dy over dx. All right, so that takes care of the left side of my equation. On to the right side. So 3x derivative is going to be 3, so this equals 3 minus derivative of 2y is going to be 2 dy over dx, because again, we're using the chain rule anytime we take the derivative of something with a y in it. And we have to get dy over dx isolated. To do that, I have to distribute this cosine of x plus y term. So I've got the cosine of x plus y plus cos x plus y times dy over dx on the left side. The right side is completely unchanged. I just distributed on the left. Now I'm going to try to get the stuff with dy over dx to be on the same side. I'll just keep it on the left side. So on the left side, I've got cosine of x plus y dy over dx. I'm going to add this 2 dy over dx to be over there with it, because I want everything with the dy over dx on one side. And now the stuff that does not have dy over dx got to go over to the other side. So we have a 3 that was already over there. We have this cosine of x plus y that I'm going to subtract to be over there as well with the 3. At this point, since I only have dy over dx's on the left side, I can factor out a dy over dx, leaving me with cosine of x plus y plus 2 inside that parentheses. And at this point, to get dy over dx by itself, I'm just going to divide both sides by everything in this parentheses. So when the dust settles, I've got 3 minus cosine of x plus y, all of that over cos x plus y plus 2. All right, well, now we have to match it with an answer choice. It looks like that's going to be equivalent to answer choice D. On this problem, we're trying to find the slope of the tangent line to this curve at -1, -1. So I have to first take the derivative of this and then plug -1, -1 into that. Since I can't isolate y, I have no choice but to use implicit differentiation. So I'm going to go left to right, take the derivative of y with respect to x, and anytime I take the derivative of something with a y, I have to give it a dy over dx tail because I'm really using the chain rule on an inner function y. All right, so 4y squared, that derivative is going to be 8y dy over dx, plus now I have to take the derivative of xy. That's going to require the product rule, so let me bust out the box and ribbon for that. So I've got an x and a y, those are my factors. Derivatives of those are going to be 1, and this will be dy over dx. So that's going to be, using my ribbon here, that's going to be plus y plus x dy over dx. And that's going to, let's see, we're going to subtract the derivative of 2x squared now, so that's going to be minus 4x. All of that equals 0, derivative of 3. At this point, we're going to get the dy over dx's on one side and everything else on the other side. This 8y dy over dx can stay on the left. So can this x dy over dx. But this y, got to go. Doesn't have a dy over dx, got to go over to the other side. So we have a equals minus y and then a plus 4x to get this over there as well. Now that I only have dy over dx's on the left, I can factor out the dy over dx. That leaves me with 8y plus x inside of parentheses, which I can now divide both sides by. So dy over dx then is going to be negative y plus 4x, all of that over 8y plus x. But I'm not done. I still have to figure out the derivative of this thing at the point -1, -1. So now I'm going to plug -1 and -1 in for x and y. Now the good news is I'm plugging in the same thing for x and y, so I don't have to figure out which one is which. This is going to be -1 up here, plus 4 times -1. This is x -1, but again, it doesn't really matter at this point. We've got 8 times -1 minus 1, and let's see what all that comes out to. So this is going to be 1 minus 4, so that's -3 up top. And then on the bottom, I've got -8 minus 1, so -9. And we can reduce that to 1 over 3 to match answer choice D. Oh, there it is, 1/3. All right, now we're done. On this one, I'm trying to find dy over dx for this expression, this equation. Since y is pretty much impossible to isolate, I'm going to have to use implicit differentiation. So taking the derivative from left to right here, I've got the derivative of cosine of something. This is going to require a chain rule. That's going to be negative sine of something, negative sine of 4x minus y, times the derivative of the something. So derivative of 4x minus y, that's going to be 4 for the 4x, minus dy over dx, because y is an inner function. So I have to use the chain rule whenever I take the derivative of y. And now this is going to equal derivative of x, which is 1, plus y derivative is dy over dx. All right, to isolate the dy over dx's, I'm going to have to distribute this negative sine 4x minus y. So I end up with negative 4 sine 4x minus y plus sine 4x minus y dy over dx. So that's kind of gnarly to distribute, but we made it. And then the right side is unchanged. Now I'm going to move all the dy over dx's over to the left side and everything else over to the right side. So on the left side, I can keep my sine of 4x minus y dy over dx. That can stay. And I'm going to subtract this dy over dx to get it over to the left side. Moving over to the right side, I'm going to add this 4 sine 4x minus y. And there's already a 1 over there that I'll just keep around. So now that I only have dy over dx's on the left, I can factor that out. That leaves me with sine of 4x minus y minus 1 in a parentheses. And the right side is unchanged. Now I'm going to divide both sides by the stuff in the parentheses here. And that gives me this mess that dy over dx equals. So now we just have to match this with one of the answer choices. And let's see here. It's a little bit out of order, but choice D, 1 plus 4 sine of 4x minus y, that matches the numerator. And the denominator, Well, let's see here. This is a little bit messy. We've got -1 plus sine of 4x minus y. Yep, that's right. That matches. So then choice D. On this problem, they're telling us that the point -2, 4 lies on the curve in the xy plane given by this crazy equation. So we have f of x times g of y, and we don't really know what those do, but we've got a few table values, and we're told they're differentiable. And then we have a 17 minus x minus y on the other side. Okay. So we've got, let's see here, we want to find the value of dy over dx for this equation at the point -2, 4. So we have to take the derivative of this monstrosity and then plug in -2, 4. Well, I'm going to have to use implicit differentiation. There is no way to isolate y in this problem, especially if it's stuck inside this function of y, this g of y here. So let me take my derivative on the left side to start with. That's going to require the product rule. So let me get out the box and ribbon here. So I have an f of x and a g of y, and their derivatives, which are going to be f prime of x and g prime of y. But I have to be careful here. Since this is a function of y and we're using implicit differentiation, I have to always multiply by a dy over dx because I'm using the chain rule. Y is an inner function. So we have a dy over dx there because I just took the derivative of something with a y. Okay, multiplying this out with the ribbon now, I have f prime of x times g of y plus f of x g prime of y dy over dx. And that was just the left side. We still have a right side to deal with. Now the good news, this isn't so bad. 17's derivative is just 0. Negative x becomes -1, the derivative of negative x. Negative y is just going to be a minus dy over dx. So that wasn't too horrible. At this point now I have to isolate dy over dx. So anything with a dy over dx is staying on the left side. Anything without it, moving over to the right side. So I can keep this f of x g prime of y dy over dx term right here on the left side. But I want to add this dy over dx on the right side over to the left side so that I have all of those dy over dx's together. And now this f prime of x g of y has to move over to the left side, so I have to subtract it. And then I still have a -1 on the right side, so I'm just going to leave that there. At this point, since I only have dy over dx's on the left side, I can factor out dy over dx. That leaves me with f of x g prime of y plus 1 inside my parentheses. Right side is unchanged, but now I'm going to change it because I'm going to divide everything by this craziness inside these brackets here. So at the end of the day, my dy over dx formula is negative f prime of x g of y minus 1 over f of x g prime of y plus 1. Boy, what a mess. We still have to plug in -2, 4. So let's take care of that now. So plugging that in the numerator now, I've got negative f prime of -2, g of 4, and I have a -1 there as well. Don't want to forget about that. Down below here, I've got f of -2, g prime of 4, and a plus 1. So let's plug in these things using this table now and clean up this mess and pick one of these answer choices. So let's look at our numerator first. F prime of -2, looking that up in the table, is 4. So this is -4. And then g of 4 is 5. So we have -4 times 5, which is negative. Let's just leave it like that for now. We'll multiply it out later. So we have -4 times 5. Downstairs here we have f of -2. That is 3. G prime of 4 is 2. So we have 3 times 2 plus 1. And now simplifying this to get an answer choice, this is going to be -20 minus 1, so -21. And that's going to be over 6 plus 1, which is 7. So this reduces then to -3. And that is going to be answer choice C.